This is lecture 26, network theory. So in this lecture we are going to see the interconnection of two port networks. So in the previous two lectures we are discussing about how to find the two port parameter, that is Z parameters, Y parameters, and H parameters, G parameters, and transmission parameters, inverse transmission parameters. So the 6. Now suppose if there is a two port networks are connected in series. See, this is network A, this is network B, and is connected in series fashion, right? Because I1 is entering and this I1 should come back at the again input side. Similarly here I2, so it will be series connection. Now how to find the Z parameters for this network is very simple. First we will find the Z parameters for network A like this. V1 A is equal to Z1A I1A plus Z1 Z11A Z12A I Similarly V2A is equal to Z21A I1A plus Z22A I2A. So what is the Z parameter? So I will assume as ZA is equal to Z11A, Z12A, similarly Z21A, Z22A. Similarly for this network, the network B, I will find ZB as like this simple: Z11B, Z12B, Z21B, Z22B. Right? Now if this is V1, so if I apply KVL here, so what is this total V1 is equal to V1A plus V1B, right? So that means the overall Z parameters will become ZA plus ZB, right? So it's very simple to find whenever the two networks are in series. So we will find independently the Z parameters for network A and network B, then simply we will add. Similarly, if two networks are connected in parallel connection of two port networks, something like this. So whenever there is a parallel network, so we will find for each network we will find for the YA, that is Y11A, Y11, Y12A, similarly Y21A, Y22A for network A. Similarly YB is equal to Y11B, Y12B, Y21B, Y22B. Now the overall Y parameters will be added, because see here I1 is the dividing between two networks. So that means the total current I1 is equal to I1A plus this is I1B, right? So that means the overall Y parameters will become YA plus YB, right? So whenever the two connects are connected in parallel, so we will find individually the Y parameters, then we will find we will add the both parameters and we will get the overall parameters. One more connection is there. It is cascade connection of two port networks. Similarly, network A, network B is connected one after another. That is, output of the first network is connected to the next stage input. So that is like a cascade connection. So when the two networks are in cascade, we will find the transmission parameters for network A and network B, right? So to find overall transmission parameters, we will have to multiply the two transmission parameters TA and TB, right? So it's very easy to find this T parameters, then we can find easily by multiplying, right? So it is like this, right? So I'll assume as AA, then BA, CA and DA. Similarly TB means A small b and B small b, C small b and D small b. Something like this we need to find, right? Now we'll see questions one by one. Examples we'll see. Suppose this is the network given. then find overall Z parameter, or simply they will ask Z parameters. Now by looking the circuit, we can easily tell these two are in series. Now so we'll take first this one separate and this one separate. So this is 1 ohm, this is 2 ohms, this is 1 ohm. So network A, suppose. So I can find ZA directly because we know the conditions. This is the common, so it will be 2 ohms here. Now to find Z11, we have to add 1 plus 2, 3. Similarly, this one we will add 3. So that is ZA. Now next to network B is simply like this. This is 1 ohm. Now how to find this ZB is equal to, see this one is between from input side and output side is common, so it will get 1 1 1. Now to find Z11, here actually there should be some resistance, but it is 0, so 0 plus 1 1. Similarly 0 plus 1 1. So this is the ZB. So what is the overall parameter? Z is equal to ZA plus ZB. Now each parameter, see Z11A, Z11B. So 3 plus 1 4. Similarly these two, 2 plus 1 3. Similarly 2 plus 1 3. Then 3 plus 1 4. So this is how to find the overall Z parameters. Similarly, so one more example. Suppose some circuit is given like this. So find the Y parameters of the network. So two networks are in parallel, so we'll have to take one at a time. So I will take like this. So J4, see here C means that means it is Y some YB. Similarly, this is also 3 Siemens, so this is, I will take it as YC. This is 2 Siemens, so this is, I will take it as YA. Right? This is network A. So what is the YA parameter matrix? We know this is YB, which is common, so minus YB, that means minus J4. Similarly here also minus YB, that is minus J4. Now to find this Y11, so we have to add these two. That will be 2 plus J4, because the units are given as Siemens, so we can directly add. If units are given as ohm, so it will become 1 by 2 plus 1 by J4, etc. Similarly to find Y22, so simply we'll add. So this is 3 plus J4. Right? Now if I take this circuit, again it is a Siemens, so one is 4 Siemens. This is minus J6 Siemens. Similarly, this is minus J2 Siemens. Right? Same we will find, that is network B Y parameters. So this is 4 Siemens is common. So minus 4, that is minus YB or minus YC, etc. Then we have to add these two. 4 minus J2 here, and here we need to add these two. 4 minus J6 here. So total Y is equal to YA plus YB. Now see each term, 2 plus J4 plus 4 minus J2. So 2 plus 4 6 minus J2 plus J4, so it will become 6 plus J2. Next one minus J4, this is minus 4, so minus 4 minus J4. Similarly this is minus 4, this is minus 4, so minus 4 minus J4. The last parameter is 4 minus J6, 3 plus J6. So 3 plus 4 7 minus J6 plus J4, so we will get minus J2. So this is the overall Y parameters. Right? Next one is something like this. So find the transmission parameters of the circuit in figure. Now something question is given like this. So we have to take the parts. See these two, if it is parted here, so we'll get one network and we'll have one more network. So two networks are in cascade. So first we need to find T parameters for this network, then T parameters for this network. So I'll take, this is 4 ohms and this is 1 ohm. So this is, suppose V1, suppose this is V2. So this is network A, so V1A, V2A. This is I1A, this is I2A. Right? Now to find the T parameters, so what is the V1 is equal to AV2 minus BI2 and I1 is equal to CV2 minus DI2. Now first we will find I2A. So here A, 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 A. So if I make I2 0, so I will get A and C. So if this is 0, so what is this? Directly V1A is equal to 4 plus 1, 5 I1A, because this current is 0. So what is V1A by, so this is equation 1. But we need to find V1A versus V2A. Similarly, I1A versus V2A. So if I find the V2A, because this is current is 0, V2A is nothing but I1A into 1, right? So what is this I1A by V2A? So I1A by V2A is nothing but C, which is 1, right? So what are the units? I by V means we will get Siemens. Anyway, it's not required. Similarly, to find A, V1A by V2A. So V1A we got 5 times of I1A, and V2A we got I1A. So what is V1A by V2A is nothing but 5 by 1. So 5. So we got A and C for network A. Similarly, to find the B and D, so V2A becomes short circuit. So whenever it is short circuit, so V2A will be 0. So whenever it is short circuit, this also will be gone. So simply the circuit will become like this: 4 ohms, right? So this is I2, this is I1A, I2A, this is V1A. So what we require? So this is 0. So V1A versus I2A. See here, if I apply KVL, V1A can be equal to 1 is I1A into 4, that is equation 1. One more is V1A is equal to minus 4 into I2A, because I2 is the opposite of the I1A, right? So we need condition V1A versus I2A, right? So V1A by I2A we got minus 4, which is equal to see, V1A by minus I2A is nothing but minus 4. We can say minus B. So what is B? Is equal to 4, right? Similarly, to find D, I1A versus minus I2A. See here, so if I divide these two, so 1 is equal to 4 I1A by minus 4 I2A. So 4 cancel. What is I1A by minus I2A is nothing but D, which is nothing but 1, right? So what is the TA parameter is nothing but A we got 5, B we got 4, C we got 1, D we got 1, right? Next we will take the remaining cycle, that is 8 to 6. Then we have to find the again the T parameters. 8 ohms, this is 2 ohms, and this is 6 ohms. So same method we will use. Suppose V1, V2, I1, I2. So I am directly finding the parameters. See, I will use different approach here. So to make I2 0, then it's a somewhat lengthy procedure. So this is I1 is coming, I2 is coming. So what is this current? I1 plus I2. So if I apply KVL here, so what is V1 is equal to I1 8 plus 2. So directly 10 I1 plus 2 I2. Equation 1. Similarly, if I apply KVL here, what will get? V2 is equal to 6 plus 2, 8 I1, sorry, not 8 I1, 8 I2 plus 2 I1, because I1 is only through 2 ohms branch. Now we need V1 versus I1. So from this second equation, what is I1? I1 is equal to V2 minus 8 I2, and this 2 is by 2. So 1 by 2 by 2. So 0.5 V2 minus 4 I2. So that is I1. So what is this? This is C and this is D. Now if I substitute back, so I will get the A and B also. So 10 I1. So 0.5 V2 minus 4 I2 plus 2 I2. So if I rearrange, so 10 into 0.5, that means 5 V2. So minus 40 I2 plus 2, right? So plus minus 40 plus I2, it is nothing but, so 5 V2 minus 38 I2, which is V1. So what is the TB? Is nothing but 5, 38.5 4. So now what is the total parameters? So it is TA multiplied with T2. So TA we got TA 5411. TB we got 538.54. To find overall, so we'll multiply this two. So 5 into 5, 25 plus 2. Next one, 5 into 38 plus 16. Similarly this one, 1 into 5 plus 0.5. So 38 into 1 plus 4. So this is the total T parameter matrix. So this is 27, 5.5. This is 42. So 5 into 38 plus 16. 40. 190 plus 16. So 190 plus 16. So 206. This is the total. So this is the total T parameter matrix, right? So this is how to do this type of problems whenever there is series or parallel or cascade connections. They may ask, so suppose question is given like this, series connection is given, but they may ask what is the H parameter or H12, H21, right? So we can use either first we'll find the total T parameters, then we can convert into H parameters, right? That is also we can do. Next we will see we'll do one numerical based on this TwoPort network. Somewhat it's a lengthy question, but it is very easy actually. So it is came in GATE 2008 for linked answers. So one network is given and this is ammeter and the two switches are given. This is ammeter A1 and voltmeters V1 and V2, right? So some conditions are given. So in first condition, S1 is open, then S2 is closed. So this is open, it is closed. Then A1, that is ammeter A1 reads 0 amperes, V1 reads 4.5, V2 reads 1.5 and A2 is 1 ampere. Similarly, for condition 2, S1 is closed, S2 open. Then A1 is equal to 4 amperes, V1 6 volt, V2 6 volt, A2 equal to 0 ampere. Then what is the Z parameter matrix as well as H parameter matrix? Now before solve this question, first we need to write the equations first. Always remember. So V1 is equal to Z11 I1 plus Z12 I2, right? Similarly, V2 is equal to Z21 I1 plus Z22 I2. Once we know this, then we can easily solve. Similarly, H parameters means the first one is V1, which is H11 and this is I2. So H11 I1 plus H12 V2, H21 I1 plus H22 V2. Now then we can solve easily. So S1 is open means A1 reads 0. That means I1 equal to 0 ampere and V1 is 4.5 volt and V2 is also 0.5 volts and A2 reads 1 ampere. That means I2 we know 1 ampere. Now if you see this one, I1 is 0 means, so we will get two conditions, Z12 and Z22. What is Z12? Z12 is equal to V1 by I2. So what is V1? 4.5 by I2 is 1. So 4.5 ohms. Similarly, Z22 is equal to V2 by I2. What is V2? 4.5 by I2 is, so V2 means 1.5, not 4.5, 1.5 by 1. So 1.5 ohms, right? So this is the first condition. Now from the second condition, A1 reads 4 ampere, but S1 is closed, S2 is open. That means, so I'll take here, right? So I2 is equal to 0 because S2 is open. So anyway, it reads I2 is 0 and I1 it is 4 amperes, V1 6 volt, V2 6 volts. Now if you see the second equation, I mean I2 is 0 means I will get Z11 and Z21. So what is Z11? V1 by I1. So V1 is given 6, I1 is we got 4. So it is nothing but 1.5 ohms. Similarly, how to find Z21? Z21 is nothing but V2 by I1. So V2 by I1. What is V2? 6. I1 means 4. So same we will get 1.5 ohms. So this is how to solve the Z parameters. What is Z parameters? Z is equal to Z11 we got 1.5, Z12 we got 4.5, Z21 we got 1.5, Z11, Z22 1.5. So this is the Z parameter matrix. Now we will solve for H parameter matrix. Now I'll take one more page. So see, we already got Z parameters. So Z parameters, what we got? 1.5, 4.5, 1.5, 1.5. Now from this Z parameters we can find easily V1 and so what is this? Z parameters 1.5 I1 plus 4.5 I2. V2 is equal to 1.5 I1 plus 1.5 I2. Now we need to rearrange these equations like this. So from the equation 2 I can make like this: 1.5 I2 is equal to, this is going the other side, minus 1.5 I1 plus V2. So what is I2? Minus 1.5 by minus 1, 1.5, it is minus I1 plus 1 by 1 by itself, 2 by 3 V2. This is equation 1. So I2 means we will get H21 and this is H22. Now if I substitute here this I2 in this expression, I will get V1. That is V1 is equal to 1.5 I1 plus 4.5 into minus I1 plus 2 by 3 V2. See here, 1.5 minus 4.5 minus 3 I1 plus, so this is 9 by 2 into 2 by 3 V2. So 2 to cancel, this is 3. So minus 3 I1 plus 3 V2. So this is V1. So this is H11, this is H12. Now what is the H parameter? H parameter is equal to minus 3 comma 3, and from this expression minus 1 comma 2 by 3. Right? So this is how to find the H parameters. Right? Next we will see some equivalent circuits which is somewhat these equivalent circuits may be useful in analog electronics. So for that reason I am telling here. So Z parameters equations can be written like this. So how to model this one is, see V1, so it's like KVL. So that means Z11 into I1. So I1 into some impedance Z11, but this one is some voltage source which is dependent on the I2, right? So that means this is a reverse transmission impedance, that is from 2 to 1. Similarly, from the output side, there is the impedance Z22 which is multiplied with I2. Similarly, there is a dependent voltage source which depends on I1, that is from the input side, and this is the Z21 which is forward transmission, right, from 2 to 1. This is the reverse one. Similarly, I can go for Y parameters. So from the equation only we can derive like this. See, I1 is equal to Y11 into V1. So here we need to apply nodal analysis. So I1 is equal to V1 by Y11. So it is not 1 Y11, it is 1 by Y11. Then only V1 by 1 by Y11 means Y11 will come. Now this is again dependent current source which will depend on the output voltage. Similarly, if I write for I2, it is Y21 V1. So V1 is dependent, so it is the current source. This one is again 1 by Y22, right? So this is equivalent. Similarly, if I go for G and the H parameters. Now what are the H parameters? The first one is voltage source, which is V1 is equal to H11 I1 plus H12 V2. This is I2, which is H21 I1 plus H22 V2. So first equation is the mesh analysis. So V1 is equal to some impedance H11 which is multiplied with I1, but there is a voltage dependent source which is dependent on the output voltage. So that's why H12 V2. So again this is a reverse voltage gain. H12 is nothing but V1 by V2, right? Similarly, the output is nodal analysis. So I2 is equal to this is the current gain. So H21 into I1, dependent current source, and see actually I2 should be H22 times of V2. So it should be 1 by H22 because H22 is nothing but admittance, right? So this is very helpful when we go for the small signal model of the BJT. So generally we will get some HI here because this H1 is the impedance. Generally we will neglect this one. If you go for this one, so this one HR into V2 or generally V0, right? Here we'll get this is HF, that is forward current gain, which will depend on the I1. So there we'll see IB here, IB, and here we'll get 1 by HO, right? And this is V0 and this is VA. So because why the H parameters are important in the analog electronics means, so in this we'll have impedance, input impedance, output impedance, voltage gain and current gain, right? So that is the reason why we use this hybrid parameters in analog electronics. So similarly we can go for the G parameters. So this is V1, so this will be opposite, that is I1, so that is I2, so we will get V2. So these are the parameters, then we can apply like this. So the remaining ABCD transmission parameters, etc., we can go as like this, right? So this is about the total 2-port parameters. Generally in the GATE 2017 no question came from the 2-port parameter, right? So in GATE 2018 we may expect from this 2-port parameters or 2-port networks questions, right?